Hello everyone, welcome to 1045 Engineering. We are here with yet another video in our Grind 75, a Better Blind 75 coding series. So today's problem is on serializing and deserializing a binary tree. Let's quickly jump into the problem statement, understand it and start solving. Okay, last time we have solved the minimum window substring. We have reached the hard category now. Let's start with you can find it in the list though. Let's start with the serialize and deserialize binary tree. Okay, serialization is the process of converting a data structure or object into a sequence of bits so that it can be stored in a file or memory buffer or transmitted across a network connection link to be reconstructed later in the same or another computer environment. Okay, design an algorithm to serialize and deserialize a binary tree. There's no restriction on how you serialize deserialize algorithm should work. You just need to ensure that a binary tree can be serialized to a string. Okay, we have to serialize it to a string, and this string can be deserialized to the original tree structure. Okay, clarification, the input output format is the same as, okay, another question. You do not necessarily need to follow the format, so please be creative and come up with different approaches yourself. Okay, and then we are given a tree. Of course, input and output would be same since we are going to serialize and deserialize it. Okay, so before we start, we don't actually have to do much. I know the question comes from the hard category and it is really hard if you have not seen this question before, but if you have seen this question, it is not that hard at all we have to do is convert this tree node into a string, and then on the other end we have to receive it as a string like here and convert it back to a tree node, right? So we are given in the format of tree node, we have to return in form of string, then we'll receive in format of string in deserialization process and return as tree node. Okay, so it's fairly simple problem. Let's start with it. Okay, we are going to use string buffer so that we can, well, so what we are going to do is we'll simply use a string buffer, and by one we'll add all the values to the string. We will use a pre-order traversal for this, and similarly we'll use the pre-order traversal again while deserializing and deserialize it back to a string. Okay, back to the tree node format. Okay, with this let's start with our solution. Okay, what do we need? First we need a string builder. String builder, let's call b is equal to new string builder. Okay, now we'll create a helper class or a helper method and then use it directly. Okay, let's create a helper method. So helper method, because since whenever we are working with trees we want to recursively call the same method on the left child and the right child. Helper method to be called in recursive fashion, to be called recursively. Okay, let's start. Private void, let's name it serialize helper. This is one of the most common implementation for this solution. Tree node, and then we are going to receive a string buffer, string builder sp. Okay, so let's call our string builder. Oops, so we can say serialize helper, will pass root and sb to it. Okay, after this our string builder will be completely formed with a serialized output of tree node. So we'll simply return it, return sb, and then convert it to string format since we have to return string to string. That's it, simple, right? Now for as we go with any recursive calls, we first have a base case to end the call and end the recursive call, and similarly to come out from the loop. So we'll say base case also to check if the given node is null, right? If the node is null, return null. Okay, so we'll check if node is equal to null. We'll say sb dot append small null, and then in the end dot append comma. Why? Because since we need to regenerate it in the format 1 comma 2 comma 3 comma null and all, we'll use the comma in the end. Okay, so this would be the if case. Else it is not null, so like the first node we are given the head root, right? Else we'll add this value, so we'll say sb dot append node dot value dot append and comma. That's it. And now simply we'll call the same serialize helper on the left node and the right node. That would be this and this one. Okay, so let's call it. Okay, so we'll say serialize helper, we pass node dot left and sb. Similarly, serialize helper node dot right sb. So this is for left child and this one is for right child. That's it. That is all that we have to do in our serialization process. Okay, now in the deserialization process, again we are given in the form of string data. We'll take it as part of our linked list and then we'll deserialize it. Okay, so we'll say okay, okay, so let's create a linked list for this. It's a key of string nodes is equal to new linked list of, so we'll directly create it from the data string arrays dot as list function. So data dot split, since we have received it in format of commas, we'll remove the commas. Okay, that's it. So now we got a queue. Now we got a queue of nodes that has all the values from the string data, and now we have already split it in the format. We have already split it by the comma. So we'll have 1 2 3 null null 4 5 like this, and now simply we'll deserialize it. Okay, so now we can say similarly like how we did for serialization, we'll do it for deserialization. So we can say return deserialize helper, will pass the nodes. Okay, let's create a deserialization method. Helper method to be called recursively. Okay, so we can say private, we need to return in form of tree node deserialize helper queue of format string nodes. Okay, now again we'll check for the first value. So string value is equal to nodes dot poll. We'll check for the null. So we'll say base case if null return null, right? So if value dot equals null, again as we discussed, it's the breaking condition and the base case. Okay, so we can say return null in this case. Otherwise that it is not null or it is not the child, like for fourth left child would be null, fourth right child would be null, as we did for serialization. For deserialization we'll simply receive them as null and null. Okay, otherwise if they're not null, let's form a tree out of them, right? So we'll first form a node, tree node is equal to new tree node, right? Now but what should we pass? We can actually pass a value as well, so that it will be assigned to the tree node's value. So we can say we need to pass the value integer dot parse int and well, because it's in string format. Oops, not value. Okay, now same thing we are going to do it for the left child and the right child, since we are performing pre-order traversal, right? So we can say node dot left is equal to, we'll call the same method deserialize helper, and we'll pass nodes. Then node dot right. Why just simply nodes? Because we already removed the first element when we did the node dot poll. That's what we are going to do for each string element, right? Node dot right is equal to deserialize helper, and we'll pass nodes. Okay, that's it. And in the end, from this we can say return node. That's it. That is the whole solution. So yes, if you are unaware of the solution, it might seem like a really hard problem, but once you have seen the solution, once you have solved the solution, you already know you just have to convert it into the string format for the serialization process, and for deserialization process you have to convert it from the string to the tree node format. Okay, let's run it. I'm hoping no compilation issues this time at least. Oh great, this is one of the good days. And let's submit. Okay, I was actually expecting better, so you know what we do, we always resubmit it. Yeah, okay, that's it. It beats 84.29% of users with Java. So yeah, there could be better solutions as well. I'm aware of this one, and this is one of the most frequently used one as well, and plus very easy to understand. So that's it from today's video, everyone. For anything, please let me know in the comment section. And yes, the overall time complexity would be O of n, where n represents the number of nodes for serialization as well as for deserialization. So yeah, for anything, please let me know in the comment section. And in the end, please like, share and subscribe. Thank you.